This lesson, lesson 5.1, is on rational numbers and adding and subtracting with like denominators. Here's the warm-up for you to start. You can pause now, and when you come back, you'll have the answers, and we'll talk about a couple of them. Okay, so first question is how to find the least common denominator. Describe how to find it. You're going to use the least common multiple, the LCM, in order to do that. And make sure when you're finding the least common denominator, you're adjusting the entire fraction, right? So if I had something like 1/2 and 3/4, I know that the least common denominator between these two things is 4. And so to make an adjustment, I have to multiply this denominator by 2, but I also have to be fair and do the same thing over here. So that way I have 2/4 and 3/4, and now they have a common denominator. Remember, you can just find a common denominator, but finding the least just helps you out a little bit. Let's look at these two, or question number 2. Which fraction is the greatest one? So looking at this first example, there are a couple of different ways we could do this. The common denominator between 4 and 9 is 36, and so this would have to be multiplied by 9, this would have to be multiplied by 4. Make sure that you're being fair, and so these new fractions would be 12/36, I'm sorry, that should be a 9, will be 27/36 and 28/36. Well, now, because the denominators are the same, I can just look at the numerator and I can clearly see that this one is a little bit larger. Another way to do this is by actually doing this sort of cross multiplication shortcut to finding common denominator. Between 15 and 18, sometimes using the least common denominator is not super convenient, but I can just find a common denominator, and so I can do 15 times 11, which is 165, and then 13 times 18, which is 234. Okay, this is just another way of finding a common denominator and figuring out what the adjustment would be of the numerators. It's a shortcut. And so I can clearly see that 13/15 is larger than 11/18. Let me show you both examples, or both methods, on this last example, on example 3. And that way you can kind of see where the shortcut comes from. If I'm finding the least common denominator here, that would be 24. And so I can multiply this by 3, and I can multiply this by 4. I need to be fair. And so this gets me 21/24 and 20/24. And so clearly 21/24 is bigger, so 7/8 is the bigger fraction. Or I could use this sort of cross multiplication method, and I can say 7 times 6 is 42. And 8 times 5 is 40, and since 42 is bigger than 40, 7/8 is bigger than 5/6. And where that comes from is if I just find a common denominator, not the least common denominator. And so here I'd multiply top and bottom by 6, which gets me the 42/48. And we're just ignoring the denominator because we're just trying to compare the two. Here I would multiply top and bottom by 8. That would get me 40/48. And so it's just another way of finding them. Let's look at the third one. Here I'm simplifying. So now I need to divide. Common factors between 18 and 24 are 3. 18 divided by 3 is 6. 24 divided by 3 is 8. Oops. And look, 6 and 8 have something else in common. Whenever you do that and you have more to do, it's okay. Just do the rest. They both have a 2 in common, so 6 divided by 2 is 3, 8 divided by 2 is 4. Now we're over here with our exponents, and remember, we could just use our division rule. The exponent on this is a 1, so 2 minus 1 is 2. There were more x's up at the top, and so I'm left with just 3x over 4. So I can cancel that out. So just in case you forgot, we want to expand this out, we could totally do that. 27 is 9 times 3, or 3 times 3 times 3. And then I have 4 m's here. 45 is 9 times 5, or 3 times 3 times 5. And then I have 6 m's down here at the bottom. You do not have to do this method, but it's a really great way of showing how things can simplify, right? 3 divided by 3 is 1. M divided by m is 1, and I have 4 that are going to cancel. And so you can clearly see with this that I'm left with a 3 in the numerator, no m's, a 5 in the denominator, and 2 m's left over here. And so now I've simplified both of those. These are really important skills to know in order to add and subtract or do anything with fractions. So let me know in class if you have any questions on these warm-ups. So now let's discuss what is a rational number. A rational number is a number that can be written as a quotient of two integers. So a number that can literally be written as a ratio, hence the first part of the term rational. Basically, all that's saying is it's a number that can be written as a fraction, a true fraction, with just integer numerators and denominators. Okay, so in this pink box, I've got rational numbers covering all boxes. And clearly, all integers are rational numbers, and whole numbers, which are a subset of integers, are all rational numbers. So even if I had the number 5, that can be written as a ratio of two integers. That would just be 5 over 1. If I had 0.5, which is a decimal, that can be written as a ratio of two integers. That's 1/2. If I had 0.75, that can be written as a ratio of two integers. That would be 3/4, right? And so this goes on and on. Even if I had something like 1.25, that's 1 and 1/4, right? And so here's a whole number with a fraction, but I can rewrite that as 5/4, which is a ratio of two integers, okay? So lots of things can be written as a ratio of two integers. We say that any decimal that terminates to 0, so a terminating decimal, let me change this word here. A terminating decimal can be written as a ratio, right? So if I had something like 0.385, that can be written as a ratio of two integers because the place value ends, it terminates, and this happens to be the thousandths place. The thousandths place, right? And so then I've got 385 over 1,000, which is just the ratio of two integers. Believe it or not, repeating decimals can also be written as a ratio of two integers. 0.3 repeating is just 1/3. If I had 0.45 repeating, that's actually just 45 over 99. And so we can talk about how to do this, but know that repeating decimals are also rational numbers. So how would you be able to figure out whether what the decimal equivalent is of something, or how to write something that is a decimal as a ratio? It's just division. Remember, the fraction bar is just division. In fact, that's even where this division symbol comes from. It's a fraction bar, and then you've got the two dots that represent a numerator and a denominator. So if I wanted to know the decimal equivalent of 3/8, I could take 3 and literally divide it by 8. Okay, now remember, when you do this, you've got to make sure that you know where the divisor and where the dividend go. In a fraction, the dividend is the top number, and that's the number that goes here underneath the long division bar. The divisor is the denominator, or the bottom number. And so that's the one that goes on the outside. Because we can't divide 3 by 8, which hence why it's a fraction, we put a decimal and we add a couple of zeros in order to be able to do this. Oops, sorry about that line. And so we add a couple of zeros in order to be able to do this division, and we extend our bar, and then you could eventually get to what this would be. So if I were going to do long division here, I could get the decimal. So here, just by doing simple long division, I get that 3/8 is the same thing as 0.375. And I could do the same with each one of these. Remember, with a decimal, this literally says 7/10, so that's just 7 over 10. Here, I've got a whole number plus the decimal, and I can do those two things separately. I've got -3 as the whole number, and then I've got 5/100ths as the decimal. I can go ahead and simplify 5/100ths. This is -3 and 1/20th, right? And then I can change this into a ratio very easily. 20 times 3 is 60, plus 1 is 61. So it's going to be -61 over 20. And there's my ratio of two integers. Okay, we've already talked about putting things in least to greatest. We can do a little bit more practice of that in class. The last piece to this lesson is adding and subtracting fractions with like denominators. And so we're just going to do a couple of them together. So example number 1, if I have -4/7 minus 2/7, the denominators are the same, and so I'm just going to add or subtract the numerators. Think of this kind of like terms. If I had negative 4x minus 2x, that's going to equal negative 2x, right? We don't change the base. And so it's kind of the same thing here. It's the same idea. I'm sorry, this should be negative 6. And so negative 4/7 minus 2/7 is negative 6/7. We don't change that denominator. I have a total of negative 6/7. Example number 2. This says 1/10 minus a negative 3/10. In this example, remember whenever you have a sign, a negative sign, directly next to a parenthesis with another negative sign inside, we can just stretch out that and turn this into plus. And so really this is 1/10 plus 3/10, which is just 4/10. Example number 3. Example number 3 deals with mixed numbers. So I have 5 and 5/9 plus 2 and 7/9. You get some choices with mixed numbers. One thing that I would probably do with the mixed number is I would keep them, if I'm just adding, I'd keep them the way that they are, especially if the denominators are already alike. I can add the whole numbers. That's 7. 5 plus 2 is 7. And I can add the fractions. I can add the parts. 5 plus 7 is 12, and so that would be 12/9. The one thing that you have to do at the end is you have to adjust this. 12/9 has a common factor of 3, so that's 4/3. And then this needs to be changed to an improper fraction, because this really says 7 plus 4/3. Well, 7 plus 1 and 1/3 is equivalent, because 4/3 is 1 and 1/3. And that actually makes 8 and 1/3. Okay, so that's one way to do that problem. The other thing that you could do is just change it into an improper fraction. 9 times 5 is 45, and 45 plus 5 is 50/9. 9 times 2 is 18. 18 plus 7 is 25/9, for a total of 75/9. And then you can take out common factors here. This is divisible by 3, and that's 25. This is divisible by 3, and that's just 3. And so the answer is 25/3, which is the exact same thing as 8 and 1/3. In algebra, for the most part, leaving them improper, unless you're dealing with word problems, is the best way to go. Example number 4, negative 6 and 2/3 plus 3 and 1/3. So again, I'm going to change these to improper fractions because it can be a little bit easier to deal with. 3 times 6 is 18, plus 2 is 20/3, and don't forget that negative sign there. 3 times 3 is 9, plus 1 is 10, and so that's plus 10/3. Remember, signs are different. Take the difference, right? Negative 20 plus 10 is negative 10/3. There are no common factors. I can leave it as is. There's no reason to change this to negative 3 and 1/3. And example number 5 is now going to get us to some variables. I have 3a over 20 plus 5a over 20. Denominators are the same. I add the numerators, and that would just be 8a over 20. But don't forget to simplify. The 8 is not married to the a, and so it's got a common factor with the 20. That would be 2, and so that's 4. I'm sorry, the common factor of 4, and so that's 2/5 left there, and so I have 2a over 5. Remember, those are just fractions that can be simplified. Example number 6 puts the variable in the denominator, so that's negative 8 over 3b minus, open parenthesis, a negative 2 over 3b. Again, we're checking to make sure our denominators are the same. I see that I've got the opposite of a negative here, so I'm going to go ahead and change that to a plus sign. Denominators are the same, and now I can add. I have negative 8 plus 2, which is negative 6 over 3b. And then before I say I'm done, I need to make sure there aren't any common factors. 6 and 3 do have a common factor of 3. That leaves me with 2 over 1. So that's negative 2 over b. Now, as you can see with these, for the most part, if I have a negative, I tend to put it with my numerator. But here's the cool thing. Negative 1/2 is the same thing as -1/2, which is the same thing as 1/2. And so you can move that negative sign wherever it's convenient for you. All right, we'll talk about this more in class.